Okay, so this is a version of the position equation. Basically, it has to do with velocities. So this means that the velocity at time 2, or position 2, is equal to the velocity at time or position 1, plus the acceleration times how much time passes. So basically, if an object is in free fall, and it starts with 0 velocity, you can put a 0 there, then plus the acceleration times the amount of time. Well, the acceleration in near Earth is g, and that is equal to 9.8 meters per second squared. And we have to be careful with this because we need to indicate that this ball is going downward. So we have two ways of doing this. We can either put a negative in front of the g and say it's negative, or we can just say v2 has a positive value and specify that it's going down. But either way, we need to remember that velocity is a vector and it has a direction. So let's just throw the negative in here. So this is plus a negative value, negative 9.8 meters per second squared. And then we're going to multiply that by 2 seconds. We've got this cool cancellation here. We got cancel that second with that second squared. Now we have units of meters per second, which is a velocity. So 2 times 9.8 is, see, that's 19.6. So that's 19.6 meters per second, and it's a negative, so we've got that negative there, and it's going downward. So 19.6 meters per second, where the negative indicates downward. Now, if it weren't stopped at the beginning, then it would have a v1. This v1 here wouldn't be 0, and so we would just tack on a constant. We would basically add on whatever speed it had to begin with.